Hello, my name is Courtney and I'll be explaining how to prove geometric triangles. First, I'm going to show you some places where triangles are super important. In architecture especially, triangles are the building blocks and foundation to any successful project. Triangles are also detrimental to various sports, but most prominently you can see triangles in a golf swing. So this begs the question, which triangles do we use? We'll start with the most important, which are congruent triangles. Before we start proving triangles, I'm going to give you a short lesson on congruent triangles. When proving triangles congruent, you have 6 pairs of corresponding parts that you can use to prove the triangles congruent. You only need 3 pairs of corresponding parts to actually prove them congruent. With any type of triangle, you may use the following theorems. First is side, angle, side. And drawn on a diagram that looks like this. Next is angle, side, angle. And that can be drawn like this. The next one is angle, angle, side. It can be drawn as where the side either is before the 2 angles or after the 2 angles, like in this picture. And then the easiest is side, side, side. There are also ways to prove right triangles congruent, but let's just stick with the above for this lesson. The key to using the above theorems in a proof is looking for keywords in a given statement. Previous to this lesson, students will have gone over the properties of equality, algebraic properties, and several definitions and other theorems preceding this lesson. Some examples of keywords in a given statement are midpoint, angle bisector, segment bisector, parallel lines, or perpendicular lines. Students should also be aware of items in the diagram that you can automatically assume. Such as common sides, or vertical angles. Alright, let's work a proof so we can get a feel for all these definitions. Alright. When starting with a triangle proof, we're first going to check the given statement and mark the given statement on the diagram. So we're given that segment AB is parallel to segment CB, and we're also told that AB is congruent. Marking this on the diagram. Okay. Alright. Now we're going to look for common sides or vertical angles, and we're also going to check for keywords in the given statement. And we can see that a common side is BC. Therefore, we can write BC is congruent to BC by congruence of segments are reflected. Okay. And angles have to have one side on a parallel line. So with this, we know that angle ABC is congruent to angle BCD. This is because two parallel lines have alternate interior angles. That are congruent. So with this, we have our three parts that we need to prove the triangle is congruent. We have a side, an angle, a side, an angle, and a side. So therefore, we've proven our triangle congruent.